Welcome this lovely Sunday, February 1st. This is a review for Chapter 5.6, 5.7 Pre-Assessment. 5.6 deals with linear inequalities, which is what we see right here. And then 5.7 deals with systems of linear inequalities, where we have two of those linear inequalities. At this point, if we're going to be honest with each other, at this point, everybody should be proficient at this. And this pre-assessment should be really picking out small, very minor things on what you have yet to be proficient, master, but you should be on your A game right at this point. And this is just refresh and practice and just keeping it right there. We have an assessment on Tuesday, so let's get going. So we first have to notice the format of the linear inequality. This is in slope-intercept form. So we're going to pull out the y-intercept, and that y-intercept is going to be -2. And we're going to look at that inequality sign that has an equal sign. So on the y-axis at -2, we're going to do a closed circle. Hello. Because when we have less than or equal to or greater than or equal to, it's going to be a closed circle and a solid line. If we have less than or if we have greater than, it's going to be an open circle and it's going to be a dotted line. So in this case, it's going to be a closed circle. My y-intercept is -2, and then I'm going to use my slope, and the slope is 7/2. So that means we go up 7, right 2 from this y-intercept. 1, 2, 3, 4, 5, 6, 7 spaces. And then right 2, we make a dot, and we will connect those dots. All of these points on the boundary are going to be solutions, because it's equal to. So this is the boundary between true and false, and all the points on this boundary are true. That's why they're a solid line, and that's why it's a closed circle. And now one of these sides is going to be true, and one of these, meaning solutions, and one of these sides are not going to be solutions. So what we do is we test a point. Let's test the point 0, 0. So 0, 0 is not on this line. 0, 0 is right here. So it's not on the boundary. And I'm going to test it by plugging it into this equation. Into the equation, y is less than or equal to 7/2 x minus 2. And for the y value, I'm going to take the y value of this test point, and I'm going to take the x value for that test point, and I'm going to simplify. And we're going to look to see, is this statement true or false? If it's true, then it's a solution. If it's false, then it's not a solution. Is 0 less than or equal to -2? That is a false statement. So this point 0, 0 is not a solution. So all the points on this side are not a solution, and all the points on this side are solutions. And so we are going to always graph the solutions because we want to shade the answers. This represents all of the solutions to this equation. All right, here we go. Same thing, it's in slope-intercept form. My y-intercept is going to be 4. My slope is going to be -2, which is -2/1, which is down 2, right 1. My point, my y-intercept, my point 4, is going to be open circle because it's a less than sign. So I'm going to do an open circle. Then I'm going to go down 2, right 1, and I'm going to do another open circle. And now I'm going to do a dotted line because we do not want to include the boundary. The boundary are not solutions. And They are, sorry, they are false. There we go. That's a little bit better. There we go. They're not going to be solutions. I'm going to test a point. I'm going to test the point 0, 0 into this equation. Y is less than negative 2x plus 4. My y value is 0. My x value is 0. 0 less than 0 plus 4 is 0 less than 4. That is true. 0 is less than 4. So this point, 0, 0, is a true value, so it's a solution. So I'm going to shade this side of the boundary to represent all of the solutions. Okay, still in slope-intercept form. This time, my y-intercept is 0 because there's nothing being added to it. So that's how we would look at it. My slope is going to be negative 2 again. Probably should have picked a different one. And so I'm going to do, it's including, the boundary is including, so I'm going to do a closed circle, and then I'm going to go down 2, right 1. I'm going to connect the line. Connect it. My solutions are, or my border are solutions. That's not a very good, we want to be particular because I want to see, well, I'm going to be exact on what points you are. So notice I'm not labeling the points, but I am making sure that I can see what points you're using, and I'm going to grade you on that. And now we're going to test the point. Well, we can't test the point 0, 0 because we already know 0, 0 is true. And we know all the points on the boundary are true. I need to find either side of the boundary. So in this example, I'm going to test a point 1, 1. That's not on this line. 1, 1 is right here. I'm going to plug it into the equation. And my y value is 1. My x value is 1. Is 1 greater than or equal to negative 2? That is true. So we're going to shade the point 1, 1. The side that point 1, 1 is on. These are all the solutions. Now, number 4, we have standard form. So we're going to use the cover-up method. If we are looking for the x-intercept, I'm going to cover up the y value, which leaves me with 2x is greater than negative 4. I'm going to divide by 2. So my x-intercept is equal to negative 2. And my y-intercept, I'm going to cover up this x value. I'm left with negative y is greater than negative 4. I'll divide by negative 1. And my y-intercept is going to be positive 4. I don't have inequalities because I'm talking about points. I'm talking about where this line crosses the x and y axes. So don't worry about the inequalities here. We'll worry about the inequalities when we have to shade, but finding the x and y intercept, this inequality is not really, it doesn't play a role, okay? I just have to make sure that I isolate the x. So that's why I divided by 2, got negative 2, divided by negative 1, got positive 4. I'm looking at the inequality on whether I'm going to include or not include these points. So x-intercept is on the x-axis at negative 2. It's an open circle because it's a greater than sign. Y-intercept is on the y-axis. I'm going to do another open circle. I'm going to do dotted. And that's good. It's a good representation. That looks good. I'm going to test the point 0, 0. 2x minus y is greater than negative 4. 2 times 0 minus 0 is greater than negative 4. 0 minus 0 greater than negative 4 is 0 greater than negative 4. That's true. So this point is true, so I'm going to shade the true side. So I'm going to shade this side of the boundary. Another standard form, I'm going to cover up the y. My x-intercept equals 1. I'm going to cover up the x. I have to divide by -1. My y-intercept is -1. Closed circle. So on the x-axis, I'm going to make a dot. On the y-axis, I'm going to make a dot. I'm going to connect them. That needs to be a solid line. And let's do some arrows. Let's test the point. 0, 0. X minus y is less than or equal to 1. 0 minus 0 less than or equal to 1 is 0 less than or equal to 1. 0 is less than 1. So that again is true. Hope we get one where it's false. So we're going to shade the true side. Good. Last one on standard form, our x-intercept is going to be -6. If I cover up the y value, I'm left with x and -6. If I cover up the x, divide by 2, I get the y-intercept is -3. So that's how we use the cover-up method. I get my two intercepts. They're going to be open circles. So x-intercept is -6. Y-intercept is -3. We would like to go, oh good, still a dotted. That looks good. Arrows, testing. 0, 0 is 0 plus 2 times 0 less than -6 is 0 plus 0 less than -6 is 0 less than -6. No, that's false. 0 is definitely not less than -6, so this point is false. So all these points are false, so this must be the true side, not text. So we're actually going to shade away from 0, 0, from my test point. All right, now we move on to 5-7, where we have systems. Same thing, we're going to take each equation and graph it, and we'll do it this way. We'll do this in green. So my y-intercept equals 3, and my slope equals -1/2, which means down 1, right 2. There's only one negative here, so it either goes in the numerator or the denominator. Open circle. So y-intercept is 3, open circle. I'm going to go down 1, right 2. I will connect these dots. Try to connect them. Good. Let's make it green. Let's draw that arrow. Let's test. We're going to test the point 0, 0. Is 0 greater than -1/2 times 0 plus 3? Is 0 greater than 3? That's false. So this point is false, so I'm going to shade this side of the boundary. Notice I use little small dash marks just to show, because this is a system and we're going to have to do all of that for this equation. So my y-intercept is -3. My slope is 5/2. That's a closed circle, so y-intercept -3, up 5, 1, 2, 3, 4, 5, right 2. All right, I'm going to be a little careful about doing that point, just so we can see that point of intersection. This is a solid line, and it's going to be blue. So that's good. So that represents that line. I'm going to test. And is 0 less than or equal to 5/2 times 0 minus 3? Is 0 less than or equal to -3? That's also false. Both of them end up being false. So this point is false to the blue line. So I'm going to shade the other side of the blue line. Now, I'm looking for where in these regions, we have 4 places, 1, 2, 3, 4. Where do we get both of them true? This is false, false. This is true, false. This is true, true. And this is false for green, true for blue. So I'm going to shade that area. So that's what I need to be able to see. I need to be able to see the points that you're graphing. I need to see both of the shading. I want to see your testing information, and I want to see the pertinent information. So that would be a good example of what I would want to see on the assessment. So let's do it again. Y-intercept tends to be first. Y-intercept equals 1. Slope equals -3/2. So open circle on 1. And then we're going to go down 1, 2, 3, right 2. We'll do dotted line is good. That looks good. Let's make it green. That's good. Arrows. Let's test the point. We can use 0, 0. So 0 less than -3/2 times 0 plus 1 is 0 less than 1. Yes, that's true. So we're going to shade towards 0, 0. Let's do this. This is a y-intercept of -1 and a slope of -1/2. That's also an open circle. So open circle, down 1, right 2. So we'll do another open circle. We'll connect those dots. Oh, that was a pretty good one. We'll make that blue. Let's make this. Let's make sure we have selected it. Let's do blue. Good. Okay, let's test the point. 0, 0. And we get 0 is less than -1/2. 0 minus 1 is 0 less than -1. 0 is not less than. That's false. So 0, 0 is false. So we're going to shade this side of it. And this is where we want to, again, make sure we see where it's true for both the green and the blue. So it's false for green and false for blue here. It's true for green, but false for blue there. It is true for blue, but false for green. And then right in here is where we get the area that is true for blue and for green. I'm not going into this area. I'm just going along here. Good? Good. Number 9. Let's do that one. Y-intercept equals -3. Slope of 1/3. Open circle, -3. Up 1, right 3. Good. Make it green. Let's arrows. Let's test. 0, 0, 0 greater than or equal to 1/3 times 0 minus 3. Is 0 greater than -3? Yes, that's true. So we're going to shade up. Let's draw our other line. Y-intercept of 3 and slope also 1/3. So this will be interesting. I'm noticing. So open circle at 3, up 1, right 3. Connect those dots. Oh, sorry. Gotta make that blue. Arrows. Let's test. 0, 0 is 0 less than 1/3 times 0 plus 3 is 0 less than 3. That's true. Okay, so we're going to shade this way. And so where does it overlap? Well, this is where it's very important for us to understand what this notation means. So for this example, I'm going to show. So that would go this way. And this would go starting here this way. So where does it overlap? It overlaps in this area, just in this region between. Okay, it's not out here. It's not out here, and it's not out here. It's only true for blue here. It's false for green out here. It's only true for green here. It's false for blue here. And only in between this channel is it true for both. Number 10, we are now in standard form. So my x-intercept is equal to -1. My y-intercept is equal to +3. Close circle. X -1, y-intercept 3. Draw that line. Good. Make it solid. Make it green. We have arrows. Testing 0, 0. 3 times 0 minus 0 is less than or equal to -3. Is 0 less than or equal to -3? That's false. 0 is not less than -3, so we shade away from 0, 0. My x-intercept is going to be 4. My y-intercept is going to be -2. Open circle. So x-axis 4, y-axis -2. This does need to be dotted. And let's make it blue. Let's test. 0, 0 is 0 minus 2 times 0 less than 4. Is 0 less than 4? That's true. So we're going to shade towards 0, 0. All right, where does it overlap? Where does it be true? True is going to be in this region. Okay, that's pretty good. Number 11, x-intercept equals -3, y-intercept equals +3. Close circle, x -3, y 3. Well, that was pretty good. Don't have to rearrange that. Arrows is testing. 0 minus 0 greater than or equal to -3. 0 is not greater than or equal to -3. That's false. So we will shade away from my testing point. X-intercept equals 2. Y-intercept equals -2. Close circle. X is 2. Y is -2. Ooh, okay. Is this the same slope? Yeah, it looks like the same slope. That's a solid line. Also, blue. So this will be interesting. Let's see let's test the point. 0, 0 is 0 minus 0 greater than or equal to 2. 0 is not greater than or equal to 2. That's also false. So we'll shade away. And in this problem, there is no overlap. So we must write the word no solution. If you do not write no solution, I will not necessarily understand that you can interpret that there is no solution. Just because you graph it doesn't automatically mean that there's no solution. You have to write no solution. You've been fairly warned. And last one, I like this. We notice that this is a single variable, and that variable is x, so it's going to go through the x-axis at 1, and it's an open circle, and so we're going to get a vertical line on the x-axis. Good. That needs to be green. And we'll put some arrows. We're going to test. We can still test the point 0, 0. We're just going to only use our x value. Is 0. Is 0 greater than 1? No, that's false. So 0 is false, so we're going to shade away. And now we're going to do this. My x-intercept is -2. That's open circle. X-axis, -2. My y-intercept is +2. Dotted line. Oh, that was good. Is blue. Let's test. 0, 0 is 0 minus 0 greater than -2. Is 0 greater than -2? That's true. So we'll shade towards 0, 0. And where does it overlap? It overlaps in this area are my solutions. All right, that's good. That's some good problems. That probably took about 30 minutes, but this should have been easy. This is a good one to definitely recognize. This, not that one, not that one, not that one, not that one. This was a good one because the y-intercept is 0 and we had to pick a point other than 0, 0. So beware of some of the things. This was good because the overlap, and this was good because of the overlap. All right, good luck on Tuesday.